everyone, I'm back with another tutorial, and in today's video we're going to learn how to integrate our own reinforcement learning algorithm into the ML-Agents environment API side of the package. So this tutorial is for anyone who is using Unity3D and the ML-Agents API to train their own reinforcement learning algorithm with any environment. So for today's environment, we're going to use a built-in by Unity3D environment called Basic. And then we're going to use the reinforcement learning algorithm called expected SARSA to train the agent. So the first thing you want to do is we're going to get the environment. So we're going to go ahead. The first thing we always do is open up our Unity Hub, and you're going to want to go to Add. So this video is assuming that you already have the ML-Agents installed. You're going to navigate to your ML-Agents folder. That's what I have here. And you're going to go under Project. Don't go into Project, just select the Project folder and hit OK. And when you do that, you'll have a project folder come up. We can click on that and open it. So when we open that up, we are going to have a blank environment. So don't worry, this is totally normal. You should see your untitled scene or sample scene with your main camera direction light. And what you want to do is you want to go under here to Assets in your project window. You want to select ML-Agents. This should be loaded up because we selected the project folder when we added this new project in. So go into ML-Agents and then go under Examples. And the one we're going to use today is called Basic. You can also use any environment you want, guys. It doesn't matter. I just chose this one because it has a discrete action space. And it's very important that we choose a discrete action space for expected SARSA. In a future video, I'm going to do one on how can we use continuous action space instead of discrete. But this is a good stopping point for you to realize that if your environment is not using discrete actions, it's using continuous actions, which are floats or something like that, then it's not going to work entirely properly. So make sure whatever environment you're using to go along with this tutorial that you have discrete action spaces. So that's what we have in our basic example that Unity has given us. So once we're in the basic folder, we can go under Scenes. We see this basic scene that they've already made for us. All we have to do is drag and drop that into here, and now this scene has loaded. So the first thing you want to do is get rid of this other scene. So you can just say remove other scene, and we just have the basic scene, and we have this little really adorable little cube agent. That is our agent, and if you go under the basic in the hierarchy window, you can click on the basic agent, and in the inspector tab, now you can see our regular stuff that we're used to. We have some agent script that has a max step. We have our behavior parameters and everything that this agent needs to function properly in the training environment. So just like always, I'm going over a couple things. If you've seen the other videos, this is just a refresher. You want to make sure that you have the model set to none because we want to train our own model. We're not going to use the built-in model that Unity has provided us. We're training our own. So set that to none. You can set your inference type to CPU or GPU. It doesn't matter. I'm going to use GPU. And the behavior type, make sure you have it set to default. So if we set this to heuristic, we can go ahead and see what this is going to look like in our scene. So we have a small target and a large target, and the goal is for the agent to go to the large target. I'm not going to get into the details of what this scene is like. You can look at it on your own, but just make sure for right now, set the behavior type and the behavior parameters in the inspector window to default. Now, the next thing we can do is we can set this max step to a higher number if we want our agent to iterate through the environment before timing out. So let's just go ahead and set that to like 1,000. And we can go over here to File, go to Build Settings, and you can check your player settings to make sure that when we build this binary script, it's going to do what we want. So we definitely want to select windowed. It'll just make our life easier if we have to reshape the window that comes up. and you can just set a default screen width and height. And the only really important thing here is that you have run in background checked. So that's a necessary. Everything else is kind of optional, what you want. I think it's really helpful to have resizable window on here too. So once everything is how you want it in your player settings, go ahead and exit out. And make sure that you have development build checked. Very important. If you're going to be using the ml-envs part of the ML-Agents API, we want to have development build checked. So you can go ahead and hit build. It's going to ask you where you want to save this and what you want to name it. So I've already done that. So you would just name it and hit save wherever you want it, and it will go ahead and build that binary file for you. It might take a couple minutes to pop up and start saving it. No problem. Okay, so now we're ready to get right into Python and working with the ML-Agents package. So we can get rid of this Unity scene. I'm just going to leave it up for us in case we need it. You want to go into a terminal on your screen, and I'm just going to go ahead and zoom in a little bit so you guys can see what we're doing here. And you're going to want to go to the location of where you just added that binary file. So if I look at my folder path, I can see here that when I built that binary file, I have this binary file, basic eSARSA.x8664, whatever architecture you're running on. It doesn't have to be Linux. That's going to be in there, and you're also going to have this same name with underscore data in it. It's very important that you have those things together, and this means we're in the right folder. So you can just go ahead and jump right into Python. And I have already written the script we're going to need. I'll post it in the description below so you guys don't have to rewrite it as we go along. And so in this video, we're just going to briefly go over what kind of script you need to step through the environment and train the agent using your own reinforcement learning algorithm. So let's just pause here and think about what we've got so far. We've got a discrete environment that is already set up to train using ML agents. And so the first thing we're going to do is put in all our library dependencies. And the most important here is going to be that you pull in ML agents and you have this thing, and I'm just renaming it here, Unity environment. That's what we're going to use to pull in the environment. So the way we do that is we run this env command that just says our environment is going to be the Unity environment with a file name, whatever you named your binary file. And when you do that, it'll pull up your window. So if you see down here, it's really tiny, it's just 80 by 80. It'll come up and it'll probably ask you, do you want to force close or do you want to wait? You don't have to do anything. All you need to do is hit env.reset, and that'll reset your environment. And look, now you can see down here that we have our agent and our two balls. This is our environment. It's in real time, so we can watch it as we step through our training process. So the next thing you need to do is figure out which behavior that you're trying to train. Unity3D allows you to train different behaviors and have a multitude of behaviors in one scene. Today we're just going to work with one behavior, and so for us that is going to be this behavior name called basic. And don't worry about the question mark team 0, it's not important right now. So that's our behavior name, and we're going to need that variable later. And just to recap real quickly some other stuff that I covered in a previous video, and I'll drop that in the link, should be coming right now on the screen. You can also get some specs about that behavior, such as the number of observations and the observation vector shape. So this is really important to keep in mind as we're training any scene, to know what is the observation state vector, what does it look like, and what does the agent need in order to select an action. And you can also ask, is the action continuous or is the action discrete? And we know our action is discrete, so no worries there. So the next important thing that you need to do is you need to get the decision steps and the terminal steps based on the behavior that you're training. So we can just run this command that says env.getSteps based on behavior name. And that gives us this thing called decision steps. and you got to spell it correctly, and terminal steps. So in the decision steps, if we list that out, we will see what agents are requesting a decision. So agent 0 is requesting a decision. That means it has not reached a terminal state. And a terminal state in this environment is that it has reached the target or it has fell off the platform. So we expect, based on our agent in the middle of the platform right now, that it should be requesting a decision, which is exactly what we expect. So everything is good here. So, all right, that is the basics for getting your environment loaded in to the ML-Agents Python API using the ml-envs part of the API. So the next thing we're going to do is I'm going to show you guys what expected SARSA looks like. And expected SARSA is just a reinforcement learning algorithm that has gotten pretty good results on certain tasks, and we want to see how good it's going to be on our task. So the first thing we need to do is define two different functions. One called epsilon greedy, which is going to choose an action from our policy based on some variable called epsilon. And epsilon is going to decay as we increase in our episode iteration. So basically what that does, I'm going to try not to get too much into the nitty-gritty of the actual algorithm itself. You can always read about it online, read the paper and stuff like that. I'll link that in the description below. But basically what we're doing is we're building a framework of knowledge for our agent. And in the beginning, our agent isn't going to have that much knowledge because it doesn't have that much experience. So it's going to have to, we want it to learn to seek out new experiences in the beginning, and towards the later episode iterations, we want it to rely on previous knowledge. So as it gets better, try less to look for new experiences and try more to rely on your knowledge. So that's the idea behind epsilon and epsilon greedy. So that's the function here. This is what is actually going to select the action. So to update this knowledge framework and to have it continuously learn and get better, we need to define our second function, which is going to be called update Q expected SARSA. And that is going to take in two other hyperparameters called alpha and gamma, and all the other stuff it needs in order to make the update possible. So I'm just going to briefly explain here what alpha is. So alpha is just saying how much do you want to discount what your expected reward should be, and gamma is telling the agent how much the agent should consider future rewards over the current reward now. So this is a really important concept in reinforcement learning, is how much should I value a reward now versus a reward T plus whatever many steps down the road. And you can kind of think of that as a human, is how important is this action to me right now to get what I desire based on the grand scheme of what I'm trying to do. That's how I like to think of it. So again, there's a lot of stuff in here, but basically we are going to have something called a Q table. If you're not familiar, that is basically just an array table that's going to have a state action pair. So it's going to take in a state, and then for each possible movement, discrete movement that our agent can take in the action space, it is going to update its expected reward. And we're going to do that with incorporating the hyperparameters that I just mentioned in order for us to kind of discount future rewards and to also take into consideration our limited knowledge in the beginning. All right, so enough of that. Let's get into it. So I'm just going to go ahead and copy these two into our terminal. And this next section here, it seems like a lot of code, but honestly it's not too bad. And a lot of this stuff is reusable. So a lot of this stuff is just standard, whatever reinforcement learning algorithm you're using, you're going to want to call a lot of these same things. So the first thing you want to do is define how many different actions you can take. So we're going to do this with this command here. and we're going to call it the number of actions, so NA, the number of action space. And if we print that out, we see that we got 3. So we can go like left, right, or stay still is basically what this agent can do. For you and your environment, that might be different. So I just want to point out here, this is not the number of actions possible. So there's different in Unity environment in the ML agents. There's another thing called the action size, and that's how many different actions, separate actions that you can take. So an example of separate actions would be like you can move left or right and you can jump. Those are separate actions. So your action size would be 2, but your action shape, depending on how you set it up, would be left or right, so 2 for the first one and 1 jump or not jump, so 2 for the second one. But anyways, our action shape is 3, so that's important to know. And we're going to initialize our Q table, so I'm just going to zoom into the code over here so we can just talk about it, and then I'm going to run this all in a function. So we're going to initialize our Q table and just say for every state that we get from our environment, we're going to have our left or right or do nothing and our expected reward if we were to choose that action. And we're going to iterate through episodes, and an episode is going to terminate when we reach a terminal state. So either we fall off the platform or we reach one of these targets, and we want to keep track of our rewards. So we're going to have something called episode rewards for the whole episode just to see how we're doing. And we're gonna print this stuff out so we can see where we're at. All right, and I told you we needed to define epsilon, so that's just what I'm doing here. I'm just having a really simple decay pattern here where I say 1 over whatever episode I'm in. That's going to be my epsilon. So as we go through our episodes, as we gain more experience, we're going to have a smaller and smaller epsilon, which will in turn allow us to rely more on our knowledge. So very important next step here for anyone, no matter what reinforcement learning algorithm you're doing, you want to go ahead and call env.reset every time you run through an episode. Because this is going to, if you run through an episode, you reach the terminal state, and now you need to start the next string of episode iterations over again. So you have to call env.reset, very important. So to get the state, that's what we need to feed into our reinforcement learning algorithm in order to select an action. We need to have a state. So in order to do that, we have to track our agent, because Unity3D allows multiple agents. So we're just going to say our tracked agent is the last one. This is just kind of a simple little coding hack here, because we only have one agent. So we can just say our tracked agent is just the last one. And done equals false just means that we haven't reached a terminal step. Okay, so this is what I was leading up to, this state. So we are going to say in our decision steps.obs, this is where you get the state out. This is really important. So up here we got the decision steps from env.getSteps based on whatever behavior we're working with, whatever behavior we're training here. And we got the observations from that. And then in order to work with how I set up the expected SARSA, I had to map it into a tuple. So don't worry too much about that. So we have this state now. And when we're not done, when we haven't reached a terminal state, we're going to use the agent that we're tracking, right? So we're just going to set up our tracked agent. We're going to give it an ID. And we're going to choose an action based on our epsilon greedy policy given our Q table. Our Q table is just our knowledge, the agent's knowledge, and the current state, our decaying function epsilon, and the possible number of actions we could take, right? So if are we going to go left or right, or are we going to do nothing? So now you've selected an action. So we have this variable called action. That's what the agent wants to do next. So in order for the agent to actually take that action, you have to set that action into the environment with set.actions based on the behavior name, the action you want to take. So when you call env.setActions, you have not actually taken the action. So if you call that function, nothing has happened yet. You have just told the environment, hey, this is what we are going to do next. In order to actually do it, you then have to call env.step. So when you call env.step, your agent takes whatever action you just set it up to take, and now you can generate the next state. So the next state is just going to be, okay, I'm the agent, I took that action, what am I observing next? So we're going to do the same thing as before. We're going to call our decision steps and our terminal steps, because our agent could have reached a terminal step at this point, or maybe not, based on our behavior name. And we're going to rename this next state based on the decision steps observation at that time. Okay, so now so far we have our state, the action we took, the next state that action put us in, and now we need to get the reward that we got for taking that previous action. So you can do that by saying, if the agent that we're tracking is still requesting a decision, then you're going to get the reward with this command here. But let's say our agent reached a terminal state, then we don't actually need the reward, because we're not going to continue moving. We're going to start the episode over again. So it defaults down to this segment here, and we're just going to add the reward from the terminal steps to our overall episode reward. So back up here, we're just going to continuously add to our episode reward so we can keep track of how well the agent is doing. And the next important thing that you want to do is, this is where you actually implement your update for your knowledge, whatever reinforcement learning algorithm you're using. Or if you're not using a reinforcement learning algorithm, let's say you're using a genetic algorithm or something else, and you want to incorporate reward or do some update, this is where you want to do it. So we're going to have our previous Q table, so our knowledge before we took all these actions and got a reward. And we're going to have some epsilon probability. And that's what I was mentioning before of how much knowledge we want to take into account versus how much new experience should we try to acquire. So that's a variable for that. And we're going to say our new Q table, our new knowledge base, update that based on our parameters, our alpha, gamma, the number of actions you can take, the epsilon, and the Q table that we have. The state, the action, the reward, and the next state. So that's when we actually update our knowledge. And then before we're done, now we have to turn the previous state into the next state, right? So, or the current state has to become the state we just took. So before we did our update, I just want to be really clear here because I know it's kind of messy. Before we took our update, before we did our update on our Q table, we had a state, the action we took, and the next state that we got. Then we updated our Q table, our knowledge base, and so now that next state has to become our current state because that's where we are now. So that's just what we're doing when we say state equals next state. And that's it. That's expected SARSA, and that's how you walk through your ML-Agents environment. So I'm just going to go ahead and put this whole function into my thing. And I've gone ahead down here and I've said we have in our environment that we set up earlier here with the Unity environment from the ML-Agents API based on our binary file. So we're going to give that to our expected SARSA algorithm. And I'm just going to say run for 10 episodes just to keep it short for you guys. But these are your hyperparameters, so this is what you have to learn is best for your environment. And I set my alpha and my gamma to 0.7 just to keep it relatively simple. So if we go ahead and run that, we can see down here that our agent is actually taking actions based on our expected SARSA reinforcement learning algorithm, and it's getting rewards, and then it's using those rewards to update the Q table, the knowledge basis, and take better rewards. So if we let this run longer, it would probably get better, but you can see it started off really bad, right? Like -9 decimal points. It wasn't getting hardly any reward, and then it slowly got more positive here well, it got negative, and then it got more positive, and up to 0.6. So it was learning, and that's the whole point. So that's it, guys. It's really not too bad. So I just want to go over what we've done so far. So we had an environment that used discrete action space steps, and we built our binary executable file. We loaded that into a Python environment, and then we set that up to walk through the environment and train our agent with our reinforcement learning algorithm. And what we used in this tutorial was the reinforcement learning algorithm called expected SARSA, and we used that to train our agent. So that's it, guys. I appreciate you tuning in. Thanks for watching, and hopefully in the next video we can work on continuous action spaces, which should be really fun. So thanks for listening, and again, I'll put everything in the comment descriptions.